Another episode of diving into the previous podcast to understand what we talked about, dive a little deeper into some of the content, and actually in this instance, formally introduce our guest, Derek Edward of Harnix AI. Had a great conversation with Danu and Hamish last week, but they were so excited to nerd out on engineering stuff. Unfortunately, the guys couldn't be trusted with the formalities. So I'm bringing Derek back to chat with me for the loop back so we can find out a little bit more of some of the topics he talked about. So Derek, thank you for being with me. And I'm going to ask you to give me a bit of a background on yourself. Who are you? What do you do? Why are you here?
What does it mean to have a human in the loop?
Human in the loop.
Human in the loop. What in the world is a human in the loop? Being a human in the loop. AI in the loop. Humans in charge.
Welcome to Human in the Loop.
I love that we have to formally introduce on the loop back. I appreciate it, Elena. And you are right. When you get three engineers talking about AI, what is even identity? We're just gonna go straight into the tech, the nerd, and what is disrupting society, right? I'm Derek. I am the co-founder of Harnix AI, which is a AI consultancy in New Zealand. But I like to do this one-liner, which is we love to turn AI hype and confusion into competitive advantage for New Zealand businesses. And we have services that do that, but I think the most notable ones are very close to a philosophy of mine, which is human-centric AI. And it's my co-founder as well, Misha, is the whole idea of capability building, finding the high-value opportunities, aligning the leadership team with AI, and even moving towards prototyping phases, because I'm a software engineer by background. So I actually know how to effectively vibe code and all those jazz things. But yeah, that's a quick Cliff Note summary, Elena.
I was not even just vibe code, right? Like you said, you've cut your chops truly writing code. I think a quick dive through LinkedIn, you spend time at Air New Zealand as a platforms engineer. I know that you've been part of the Future Leaders in Tech, Flint, New Zealand organization. So whilst they may have harassed you for being the young one, you've spent years in engineering, right?
Yes, of course. Thank you. I really, it's a perfect summary. You really studied me. I guess, we did a whole trip together, and we'll touch on that later. But yeah, I have engineering experience. I studied computer engineering back in University of Canterbury. Did 4 years of that grueling computer mixture of electronics and low-level embedded programming. Moved on to C# development at Datacom for 1.5 years. Learned how to do software engineering, DevOps engineering, which was becoming a massive thing, and then became the platform owner for Azure DevOps at Air New Zealand. And so, yeah, you can say some software engineering, not too young.
Can I ask a controversial question?
You can.
If you were finishing high school in the next 1 to 2 years, would you, and you were thinking about computer engineering, software engineering, would you, with all of your knowledge now of where AI is going, would you recommend a hypothetical younger version of you to pursue a degree in that, or would you say do something else?
100%. I would actually, it becomes more valuable, because one thing that you have to realize with AI.
You're like 100% yes, do computer engineering.
Do computer engineering, do any sort of tech, right? It's this illusion that software engineering and hard engineering is going to go away. And maybe there's all this hype that has come from these extraordinary visionary leaders that have created these AI agencies, such as OpenAI, Anthropic, you name the whole thing, right? And they have both an incentive to be incredibly visionary and say all of code is going to be automated in the next 2-3 years, because there's also a sales and marketing and a commercial value behind it, right? But still to this day, there's going to be massive amount of limitations. And so we need proper engineers that understand the code. They understand the fundamentals, first principles thinking. And when we eventually get into a crazy cybersecurity incident or some sort of crazy AI's situation where we don't know what these systems are doing, we're going to rely on our engineers to help us figure it out.
Dude, I think a whole lot of second year students just breathe a sigh of relief.
Yeah, it's an illusion. Don't they're visioneering. They may have some grain of salt, to truth to it, but take it with a grain of salt, right? Like AI is rapidly changing, exponential. We don't understand exponential as humans. So in 2 weeks, a lot of things can change, but not so much to the point where I think all engineering is going to be automated. And in 2 years, I think that's a bit of a stretch.
Yeah, fair enough. I really enjoyed listening to the podcast episode that you were on with Dano and Hamish. But also it was really in depth, and I kind of was actually grateful for not being there, in the sense that I don't think you guys would have been able to nerd out so hard if I was there to steer the conversation to the lightest stuff. Um, but with that said, there are a couple of things I'm curious if you could explain further to me, like if you consider me on the noob side of AI and engineering. The Golden Gate Bridge training inside of mapping inside of a large language model. Am I getting that right?
Yeah, that is correct. Yeah, that's the paper.
Can you explain a little bit more? Because I was writing some notes and you guys were talking about, is it weights? Is it training? Is it bias? What is it that's actually being changed by a human or the system itself in order to create those changes in what the language model is serving to the user?
Yeah. So this is quite an in-depth thing. So right now, and I like to think that I am good at breaking down really complex things very easily. I think explain it like I'm 5 or 12 is actually
That's literally my prompter Claude is usually, yeah, I like that.
it's really good. So let me try my best, and it'll be a test of whether I understand this paper as well. So there's an open research right now with all of these AI models, and it's the research on interpretability. Interpretability is, can I really understand what's going on under the hood? Because we're dealing with AI systems that are giving us all this information, and we're using this information in business, right? Specifically, the Golden Gate Bridge was an experiment that looked at a very particular feature. And this feature is, by an example, a Golden Gate Bridge. And by manipulating that part of the AI model, and the way that they manipulated it is simply because when you think of an AI model, think of it like very similar to the brain, where it's a massive amount of like complexity with all of these neurons and nodes connecting to each other, right? But don't get too caught up in that. It's just very simply one part of the brain, or this neuron or this node, is called a weights and a bias. And so we say weights and bias in machine learning because at the end of the day, it's just a bunch of maths and vectors and multiplications. And that's why GPUs are a massive thing, because they can crunch it. It's an experiment to understand the inside of a model. They looked at specifically a feature of the Golden Gate Bridge, and by manipulating that particular weight, they could actually get the generation to always be around this feature, which is why Hamish was saying, like, what would I do today? Oh, you can go to the Golden Gate Bridge. Or what can I do with this money? Oh, you can pay the toll for the Golden Gate Bridge, because they manipulated that feature by increasing that node.
It felt almost like when a person gets a hyperfixation, and what's going on in the brain for a human being when they get a hyperfixation. You know what I mean?
Yeah. I think in this instance, I asked a question because I try to test Hamish, which is like, me testing someone 20 years more experienced than me is funny to even begin with. But I was like, wait, that doesn't make sense. Why would you retrain the whole model? Which is that whole, like, all of the AI models are trained on all public information. And so when an AI engineer trains a model, they don't physically go and change the nodes that I'm talking about. It's a random bunch of nodes, and then they put this data training and spend millions of dollars and bunch of compute, and the model and the nodes become trained in a very particular way. And that engineer actually has no control over that process. They, which is why Geoffrey Hinton, the godfather of AI, goes around claiming that, hey, like, we don't actually know how an AI model figures out features of a particular area. And that's that whole black box thing where, like, oh my gosh, now AI is unknown to even the people that developed it. But in this particular paper, which is really powerful, the Claude paper, it really like focuses on that potential node and seeing if it could be mapped, which is a huge win for or interpretability of an AI system.
If I recall, that was like a free to access paper, right? So I'll just pop the link to that in the show notes.
100%.
Okay, so another little note that I wrote down. The more time I spend around people talking about AI, I keep hearing probabilistic versus deterministic. And I wondered if you could just expand what it means from an engineer's point of view or in thinking about AI.
Yeah, so when there's a whole bunch of effort that goes into training a model, as I mentioned, all the latest large language models are trained on all of the internet public data. That process has a very simple maths function, which is known as a loss function, right? And that part of the process, training a model, is just think of it as pure maths, really fast maths and calculus, which is backpropagation. But all of these matter. These terms don't mean anything. What I'm trying to say is maths and a function is very deterministic, which means that you get one input and then the output is always going to be the same. An example of a deterministic system is a calculator. 2 plus 2 in a calculator is always going to equal 4, no matter what you do. The input is mappable to the output. That is the definition of deterministic. That when you train a model, it's very deterministic. You're doing maths, it goes and it trains the whole neural network. When you start using the AI model, the output is probabilistic. Probabilistic means simply it's based on probability. And what I mean by that is a large language model is simply a prediction machine. So now, because of all of the trained data, you're providing an input. It is going into the neural network, and then it's outputting a bunch of words that it thinks should come next. So if you say the cat sat on A, and then the large language model is going to predict that it's going to be mapped or whatever, But that prediction is actually a range of possible words that could come, and there's a almost like a percentage of the cat sat on a mat. So the word mat is 80% most likely to be in this position. So I'm going to put that there. But there's actually 10 other words that also could have come, and you could name them bat or bat or whatever, but they're less probable, which is why you can get hallucinations. Because if you're vague in your prompting, if you haven't provided enough context, or if you just don't know how to really leverage these large language models, then you're going to most likely get outputs that are gibberish, which is why that whole thing is probabilistic. And I think hopefully that breaks it down. Both.
Yeah, it does. I'm getting flashbacks to high school maths to compare and contrast the analogy of a calculator as a good example of a deterministic system. Then a probabilistic system would be when we all did the experiment of rolling a dice over and over in statistics class to try and map probability.
Yes, that's correct. I don't know how more to simplify this to make it, because the oversimplification of a complex thing like this could then mean that the simplification could be incorrect. It really just depends on the context, and I'm gonna that's my consultant answer.
As you alluded to before, we got the absolute privilege of traveling to Chicago just a couple of was it almost a month ago, to attend the Institute of Design's Global AI Summit on Responsible Technology, aka the Shapeshift Summit is just what it's been colloquially known as. We went to represent a New Zealand take on a global problem, which is how might AI turbocharge or cripple democracy. And it's a conversation that we started in an event more than a year ago. And as we've been thinking about it post the event, we couldn't just let the question and the conversation sit. We were like, no, this is a really interesting problem to run at. Let's try and build something. And the point at where we started to need a builder and an AI mind better than our own, we brought you into the project with your vibe coding skills and deeper understanding of AI systems, because you stay on top of every AI tool and trend and application and security review. So we get to borrow your front of the pack expertise. So we came up with this product idea to neutralize or democratize political information so that a person can verbally query an agentic system in order to get a really plain speaking answer to a complicated political topic.
We went to Chicago together. It was amazing. And you and Terry had done an amazing amount of work alongside Thoughtful, tackling whether AI could help or hinder democracy. And to come to me specifically with the idea of, look, I want to make a product out of this. Tell me if I'm crazy or if it's possible. And I very much was like, no, it is possible. We can access all of these AI systems. We can create this agentic system and we can make it into a mobile app. I'm not trying to toot my own here, but it was a difficult exercise. But the thing is, it was vastly accelerated 5 to 10 days of building an MVP because of effective prompt engineering, effective planning, using AI to help me come up with a plan, help me do the research, then determine the right tech stack, then start building right language, build the code, get it to a stage where I can deploy it onto a phone, all while being design spec was achievable in less than 10 days.
Like, bringing it back to Chicago for a second, to be in America at a very interesting time, to be in a multi-day environment where everybody's brain is on the potential opportunities, risks and rewards of what AI is going to do for society. We were surrounded by academics, people who work at Amazon, AWS, Microsoft, SAP, Google Cloud, Salesforce, DeepMind, and we don't get that kind of access freely given in little old Aotearoa. So just give me some of your impressions and reflections on what it was that we experienced. Highlights, lowlights, or personal giddy moments.
Oh, 100%. I think the biggest thing, the macro philosophy that I learned was New Zealand has the intelligence. We just don't have the competition, right? And so I genuinely think the same smart individuals also exist in New Zealand. But there was a level of like almost fandom where I was sitting right next to the head of UX at Google DeepMind that helped release Notebook LM and Google Gemini and all of those products. And for me to sit and say, hey, I actually don't like how your gems is not shareable, or I can't delete chats. And I'm not going to repeat what he said, because I think he spoke to me outside the Google vibe, but it was very interesting, and to have those personal conversations, that's so beautiful. And I'm so grateful I got to go to Chicago and experience that, right? And there's so many more people. I think that was just the most memorable one because I was fanning over that. But the reason why I say we're not that far is because
So I really, really enjoyed the guy from Waymo, Ryan Pell, and I swear he's been on my mind, and their whole company has been on my mind a lot over the last few days. Now that we've seen, tensions escalate in America, and I believe some attacks have been made on Waymo vehicles, and I don't want to speak much on a subject I haven't read a lot about, but something Hamish brought up in the podcast you guys did last week was the expectation of a human driver is like, yes, I just hope you don't kill anyone. But the expectation of an AI or an automated or robotic system is you have a zero kind of failure acceptance rate. Like, we will not allow even one death to happen on a robot watch. And I've thought a lot about that, and
that's so wild.
So
yeah, that's a whole nother topic in itself. Fully autonomous self-driving cities are the future, and
maybe this should be our next trip. Let's go to the Japan future city, the Toyota one. I would love to go there.
Yeah, that's legit. Yeah, put the business case in. We'll see.
Yeah, someone sponsor us to go to the Toyota city in Japan, and we will report back on all of the next amazing tech. Thank you so much, Derek, for joining me for this loop back and explaining a few more of the finer points of what you guys talked about last week. And yeah, getting to chat about Chicago, which we'll be fizzing about for months, if not years to come anyway.